Right, that is the first introduction of the project work, and right now I'm going to show you the connectivity, how it is being connected, and it is being powered by two 5 volt power source, and I'm using a 5 volt power source separately for the Arduino microcontroller, and also using another 5 volt power source for the servo motors themselves. And the reason being that the servo motors are actually power hungry and they consume a lot of voltage, they consume a lot of power. So I'm using two separate 5 volt power supply, one to power the Arduino and the other to power the servo motors, and also to help the shoulder servo motor, which is this one right here. I am using these springs. They are actually elastic bands, and the same. It's I'm using the idea that the same idea of spring, how a spring works. A spring stores energy and then gives that energy out when it is needed. So these elastic band, they will store the energy, and then as the servo motor, the shoulder servo motor is trying to lift the payload up, it will give the elastic band, which will act as a spring now, will give us some of those energy to assist the shoulder servo motor as it's trying to lift the payload, because the shoulder servo motor is carrying the whole payload, is carrying the link, the shoulder link is carrying the elbow link, is carrying all these links, and then whatever payload that is going to be loaded onto the robotic arm. So hence me putting this elastic band here, because from experimentation I tried it without the elastic band and I found out that the shoulder the shoulder servo motor could not really lift the whole payload up. When the load is going down, gravity helps the shoulder servo motor, so it goes down easily, and then coming back up, that is where there's a problem. Coming back up, at times it comes up to this level and then ceases. So what I did there was to introduce this elastic band to it, and that helped it move forward, backward, move, sorry, to the home position. This is the home position of the robotic arm, and in order to be able to do that, you went into the program. When the program just starts, it runs through it first of all fires off the initial position for all the servo motors, and then and then once it has finished running through the initial position, all the motors kind of like goes back up to this initial position that are there. These positions have already been programmed into the software, and then once the you start you start to run the or you power on the microcontroller. What it does is, first of all, it runs the program and runs this initial position, and then it powers all the servo motor to the initial position, which are preset angular positions for these each individual servo motor, right? And that gives the robotic arm this initial position, right? So that's what I'm going to demonstrate. And then after running through the first initial positioning of all the servo motors, the next thing the software, the Arduino board, the software listens for is for input signals from the MIT app, which is installed on this phone. So I'm just going to demonstrate that this works, and then yeah, it is quite cool. So I'll go into the actual operation right now, and in order to demonstrate that the initial position actually works according to the preset angles in the software, I'm going to displace the arm from the initial position that it is right now, and then we're going to see exactly how it works when it is being powered on. So the displacement I'm going to do is, I'm going to move the end effector down, I'm going to move the elbow down like that, and then I'm also going to move the shoulder position down. So now in this position now, it is definitely not in its initial position. So we're going to power on the software, power on the robotic arm, and then we'll see exactly how it moves to the initial position. And I'll be back with a continuation of the video. Thank you.